Hello, welcome. Good morning, everyone. Um, Today's stream is quite early as compared to the usual evening streams. This is just because, um, you know, I have a few things to do today. So, yeah. Oh, come on. Um, Sorry, I need to share something on this platform. So let's say we have this copy and you can put this here. All right. So we have a few questions here. It's just a bit of revision of the questions done before. So today is not going to be anything crazy. Um, hey, Ransom. Good morning. Uh, yeah. Today I'll have to stream early because I have um, something to do and I will have time in the evening, so I have to stream now. Okay, so let's see what we have here. Um, so here's a question. This question is really on pointers. I've not done pointers in a while, so yeah, I tried solving this question ahead of the stream, and I was also looking for other questions to solve, but it would just take me longer to solve them because my stream is going to be short today. Anyways, we'll stream. I will solve this question, um, revise some other questions, and maybe the remaining time we'll use it for trees. Right? We'll look at some trees operation, and yeah. So let's get started. So here is lit code 2824. Count pairs whose sum is less than the target. So you are given an index, an integer, sorry, an index. Ah, okay. So you are given a hold on. You are given a zero indexed integer array norms of length n and a target and an integer target, right? Return the number of pairs I j where 0 is less or equal to I, less than j, and n is less. Sorry, what am I saying? So where 0 is less or equal to I is less than j is less than n, and norms at I plus norms at j is less than the target. So already we've solved similar questions before, and when we are being asked to find pairs of numbers, right, or integers in an array, there is a chance that we are going to use a two pointer method um, to get all those values, all the possible pairs, and also there is a possibility for a brute force solution, right? So in this case, we are given this input. So here's our input, and the target is equal to 2. Now, all the possible pairs that respect or validate that goes with this condition here. So here's our condition. All the possible pairs that are in line with this condition is equal to 3. So we have 3 pairs, and you can see here there is an explanation of how the 3 pairs are found. Basically, the numbers, this is I, this is J, and since 0 is less than 1, and the sum, so 0 is less than 1 means I is less than j, and the sum at I, sum of the number at I, which is equal to 0, plus the one at j is 1 in this case, is less than the target, right? So this is what makes the count equal to 3. So you can see, note that um, 0 and 3 is not counted, since nums at 0 plus nums at 3 is not strictly less than the target. So meaning, in the case where num at 0 is -1, num at 3 will be 3, this plus this will be equal to 2, which means it's equal to the target, and this is not what we want. We want every integer less than the target. So we will not count numbers that are equal to, or sums that are equal to the target in this case. So here's what we need to do. We can use a brute force solution and start with the first number, right? And then find the sum with the remaining ones and repeat that for every number until we are the last integer in the array, right? So we can do this for every number until the last one. Now the time complexity of this solution will be O of n squared, quadratic time complexity, because we are going to run a second iteration that will check for the possible pairs within the array. So in other words, this will be our I, and the j will be the remaining one in the first iteration, and in the second iteration I will be at this position and j will start from here all the way down, and we'll repeat this until we are the last integer in the array. So this is what we have to do, and I will show you the brute force solution for this and the improved version as well. Sorry, the improved version as well. Let's go back. So I already solved this, right? And this will make it easier for me to explain and go through with you guys. So here is the improved version. I'll remove the improved version for now, and let's go back and write out the brute force solution. So for the brute force solution, we will need to use two loops, and since we are returning the count of every possible pair, right, we can do count is equal to 0 at first. You know what, let's go to the board again. This is something I was doing before the stream. I'll just scroll up and come back to that later. So let's say we are given this array. So our array is like this. I'll use a separate color. This is -1. We had -1, -1, 1, 2, 3, and 1. So -1, 1, 2, 3, and then 1, right? So here's our inputs, and our target is equal to 2. Now with the brute force solution, right, we'll start I at this point, right, at this index here. Now j will be 1 more than I, which is going to be at this position. We'll find the sum of these two integers, right, while shifting j towards the end. So in the first iteration, so we'll have something like this. We'll have 4 iterations of I, right? Then we start I at 0, j will start at 1, right? So we'll have a separate iteration for j, but j is going to be equal to I plus 1, right? It will start 1 more than I. So here's what we need to do. We'll say, you know, so we can find it, we'll call this a total, right? We'll say total is nums at I plus nums at j, right? Now if this total is less than the target t, then we increment the count, meaning we found a possible pair, right? So we'll say let's call this count c is equal to 0. So we'll say if the total is superior to the count to the target, sorry, if total is less than the target, right, is less than the target, if total is less than the target, count up, right? So we increment the count by 1. So here's what the brute force solution looks like. And the reason why this is slow is because we are running another loop, a separate loop within the outer loop, right? So here's our main loop and here's the second loop, and this is going to take O of n squared time complexity, right? Because we'll run for every integer, we'll run I for every integer in the array. So if we had four how many items do we have here? We have 5, right? So we have 5 integers in the array. So the outer loop will run 5 times, right? 5 times, and the inner loop will run 5 times, 1 less than 5 times for every iteration for every iteration of the outer loop. So here's what I mean. If the outer loop will run 5 times, right? So the inner loop will run for the first iteration of the outer loop 5 less than 1, right? So this will be run 4 times, and then in the second iteration, since this will run another time again, so this will be 2, then we'll run 5 less than 2, right? So it will run 3 times, meaning where we start from this place, we'll have -1 and 1, -1 and 2, -1 and 3, and so on, right? Until j reaches this point, and then we move I from this point towards this point, which is why this solution is slow. But the brute force solution actually works, and we'll test it out and see what happens when we run the code. So I'll come back here and say the count is equal to 0. So we'll do for I in range len of nums, right? Then we can say for j in range, so we start it 1 more than I plus 1, len of nums, and then we say total is equal to nums at I plus nums at j. Nums at I plus nums at j. Now we'll just do this. If total is less than the target, right, we'll just count up, right? Count plus equal 1, and at the end of the day, this loop will finish at some point, and then we'll return the count here. Now this will work, but this is a slow solution, right? So we can run this and see how it works. Wow, what have I done? I think, oh, okay, I'm running the code in the wrong file. So you know what, let's undo this. Hopefully I get to the point where I've done everything. I can't undo everything. I'm supposed to create a file for this, right? So this is a 2-pointer solution question. It's leads code number what? 2824. So 2 pointers question. Let's search for the 2 pointers folder. 2 pointers. I'll create the file. And I'll say lit dash 2824, right? 2824. Yeah, 2824. Sorry, I made a mistake. I should have created this file somewhere else. Let's use this. I'll say some count pairs less than target. Okay, so I'll say count pairs less than target, target. Okay, so count pairs less than target. This is a brute force solution. I'll just call this brute force. Let's refactor this, rename. You know what? Let's do this first. I'll put this here. I need to bring back the code that was here before, right? I don't know how I managed to delete all of this. That's really strange. Anyways, let me correct that. GitHub. Okay, so we have um 100 days of DSA. So here is the repo for these questions. I think that question was in linked list. So where's linked list? Linked list is here. And then we delete middle node, so 2925. So I'll copy this back and paste it in the editor. So yeah, now you can see everything is back. And yeah, so here's what we need to do now. So I'll say my solution is going to be equal to solution. Let's create an instance of the solution class, and we say print. I'll copy some of the test cases here. So we have -1, 1 and 2, target and norms here. Now we don't need this comma here, so we can put this here. All right, so we can say my solution dot count pairs, and we can pass in the norms and the pairs, the targets here. All right, so here's what we have. And the good thing about this is this will work, but it is really slow, and I'll show you why it is, right? So let's run this now. You can see we have 3. 3 was returned in the solution, right? 3 was returned in the solution. So here's the solution we have here, right? Our output here is 3, so we also have 3. But when you submit this, let me show you my submission. So about an hour ago, I did the brute force solution. Now you can see it is really slow, which is 5.7 percent. Takes 62 milliseconds, but in terms of space, it's really good, right? We are not creating any extra space in memory, but we are not really worried about space. We are worried about the time complexity. So we need to improve this solution, right? So now how do we improve this? Well, one way to improve this is to use a two-pointer method, right? Now the reason why we need to use a two-pointer method is because with 2 pointers we can quickly see search for the pairs, right? Since 2 pointers, the pointers work in the same in a linear time frame, which means at the same time in our code we can get 2 values, right, with a 2 pointer. So which also helps us get avoid which also helps us avoid using a nested loop to get the second value. With 2 pointers we can get this the pairs at the same time, right? Even if those pairs do not follow the do not how do you put it, even if the pairs violate the solution or the condition to count them as a valid pair, right, we'll still be able to get 2 values at the same time, right? We'll still be able to get 2 pairs. So here's what I mean by that. Let me show you how the 2 pointer method will work. Now, for two pointer method to properly work, we need a sorted array, right? And this works for so many solutions I have, so many questions I have solved previously. At least not so many, but like the questions I've solved previously, there are some two pointers that really work well with sorted arrays. So since our question, so here's what I noticed, right? Now you can see we have um we have this. So a pair can happen, more than once, right? So you can have more than the same more than you can have the same integers more than one in a pair. So this is what I mean by that. If I had negative one, one, two, three, and then one, right? If I chose this one as my first number, right, I can match it up with any other integer in this array more than once, meaning I can have negative one and one, negative one and another one here, negative one and maybe two, right? I'm not taking in account with the target, but I'm just using an example to explain. So meaning this one here can be stationary, right? It can match up with any other number, and it doesn't have to be at this position, right? It could be any other number here too as well. So which means that the chance for us to use um, a two pointer method will actually work. Now, here's how the two pointer method works. We have a left pointer here and a right pointer at the end. Now, why do we put the right pointer at the end? We put the right pointer at the end of the array because we know the largest value will be at this end. Now, we will do something like a binary search to shift the pointers, right, until they meet. So until they meet at a certain point, and then we stop the iteration. So, which is why, since we are going to put the right pointer at the end of the array, meaning we are sure that the largest value is going to be at the end of the array, then we need the array sorted, right? So we will transform the array. We will no longer have it in this form. Our array becomes negative 1, 1, and 1 again, then 2 before 3, right? So this is our new array. Now the two pointer method will work properly by just placing the left and right here, and then we can find the pairs at the same time. So we'll simply do left number at left. So I'll say the total is going to be number at, let's call this T. I'll put it in blue. So T is equal to nums at left plus nums at right, right? And then if this total is less than, okay, let's call this total. If this total is less than our target here is equal to 2, then we know for sure that the condition here to count this pair as a valid pair is valid. So if we find values that are less than the target, we'll shift the left pointer towards the right pointer, right? We'll shift it towards higher values until the conditions are no longer valid for us to increment or decrement the right pointer. If the target is superior to the target, if the total here is superior to the target, we'll shift the right pointer towards the left in order for us to get values that are less than the target, right? So that's like a form of binary search, um, if you ask me. But anyways, let's remove this part here. I want to do this. Okay. So another thing to note is the reason why we are putting the left and right pointer at this point is to ensure. Now you can call this I and J, right? This is also valid, but we are just trying to ensure that the left is always less than the right, right? Because the condition here is such that left has to be less than the right, I has to be less or equal to so I is less than j, I is also superior or equal to 0, and then j has to be less than n. We know n is the length of the array, right? Length of the array here is going to be equal to 5. Now j will be at, so let's see, 0 1 2 3 4. So j is at index 4, right? J is equal to 4. So already j is less than n, which is equal to 5, right? J is equal to less than n, and we know j is always going to be superior to I, so this is also valid at this point. And then we know also, let me erase this, we know also I is going to be either 0 from the start, or once we begin to shift it, the count of I, or the size of I, will increment, right? Will increase. So the value of I will increase at this point. So while we are shifting the left pointer towards the right, until the conditions are no longer valid for us to keep counting. And that condition is when left, or I in this case, is equal to the right, or j in this case. So when we do this, we will um, we will calculate the total at each point, and then find out if that total is actually, if the numbers that make up that total are actually a valid pair, right? So another thing we also need to take note of is um cases where the left, let's say the total becomes equal to the target. When it becomes equal to the target, we don't count it, right? We'll still need to shift the right pointer towards the left. So that's another thing. Now the next question you might be asking yourself is, how do we begin to count? Well, it's still the same way, but there's a subtle difference here. Now, instead of us to count by incrementing the count by 1, count plus equal to 1, right? This will not work, right? Why is this not going to work? Is because when we increment the count by 1, when the total is less than the target, we are not only counting the wrong way, but we are also forgetting that using the left and right pointers, right, the way we shift, or the way we find the pair, is not linear. So we are finding the pair at the same time, right? In the case of the brute force solution, we can count by 1, because we know once we start from I, which is the outer loop, and we get to j, right, we've counted both pairs separately. So until that time, right, we don't increment the count. But in this case, the the pairs are found at the same time, right? So which means we have to count differently. Now, how do we count differently? Well, it's simply finding the distance between where our current right pointer is from where the left pointer is. This is something similar to some questions I've solved before. So basically, we take the left pointer, right? So I'll just put it here. Let me write out the array again. So we'll have -1, -1, 1, 1, and 2, then 3, right? So let's say we have left and right here, right? Left plus right. First of all, left is less than right, right? Or let's use I and j. So I is less than j, which means first condition passed. Second condition is that j has to be less than the length of the array, which is also true, and I can be equal to 0, which is 0 1 2 3 4, right? That's also true. Now the third condition for them to be a valid pair is that the number at I plus the number at j has to be strictly less than t, right? So number at I is -1 plus 3, which is I and j, right? Number at I and j, not I and j themselves, right? So this is -1 plus 3, which is equal to 2. So this is not less than the target. This is equal to the target. So what we do instead is to move the right or the J pointer, right? We move J pointer to this point here. So J will be here now, right? So J is here, and then we calculate again. We do the same thing. We find the pairs. So we don't increment the count at this point, so because it's not valid. Now let's do this again. We'll say -1 plus 2, right? This is equal to is equal to 1. Sorry, -1 plus 2 is equal to 1, right? Is that how they calculate? Is it plus? Yes, it's plus. So -1 plus 2 is equal to 1. So which means this here is less than our target, which is equal to 2. So the condition here is true, right? So here is how we will count this time around. So we know for sure that when we continue shifting this towards this point, right, we'll have values smaller than the target, right? We'll have values smaller than the target. But when we increment this, right, when we increment this, we'll have values superior to the target. So we know, because the array is sorted, every other value from this point down, right, from this point down, will always be less than the target. So here's what we do instead. So to count, we simply take this. We'll say j count plus equal j minus I, right, which is equal to 3 minus 0, which is 3. So we know for sure that every value is going to be less going forward, right? So again, when we shift the right pointer, so when we find the target, right, we have to shift the left pointer, right? So we shift the left pointer for values that are less. And this is what happens in the case of using a pointer technique to solve a question. Whenever we find a value less than something, right, we have to shift the left pointer towards the right, or I in this case. We have to shift it because we know the larger values are towards the right, right? The larger values are from this point going forward, right? So from this point going down the array. So we find our target here, right, which is equal to 3. Now when we get to this point, when we find this again, when we do this, when we do I 1 plus 1 plus 2, j is at 2, so 1 plus 2, this is going to be equal to 3, right? 3 is superior to our target, so we can't increment the count at this point, so we leave it as is, right? So yeah, this is what we do, and we get all the possible values that we need, right? Possible counts. So the solution for that, I will write it out now. I think, oh my god, I'm so late right now. Oh my god, wow, I had some chat in the comment section. Hello everyone. Hello. um I'm seeing this, and I would love to ask if recordings for okay, the recordings for previous sessions are in the last tab. Thank you, Ransom, for answering that. Hello, Dan. My voice is low. Wow, so sorry about that. Can you hear me now? If you can hear me, that would be really nice. Anyways, so we can continue now. There is more to do. So let's write out the solution for this. I already did, right? I wrote the solution 36 minutes ago. So let's see. Oh, that's an hour ago. Wow. And you can see it is faster, right? Using 2-pointers technique. So here is it. Here it is. You know what? Let's go to the code editor and write it out again. I will come back here, right? and create a new file. So let's copy the name of this file. I'll write this rename, refactor, rename. Yeah. So this is the brute force solution. I'll call this brute force solution. Brute force. And we create a new file. This will be the actual solution here. So this is the actual solution, and we can then write out the solution like this. So I'll close this part. We don't need this now. Let's say here, I'll copy this part here because I need it. This is the template or the starter for the code. So now here's what we need to do. Obviously we are going to count, so we are creating a count variable which we will set to 0 at first. Then we will create a left and right pointer. Right now, before we do that, let's sort the array. So we'll create a sorted version of the array. Sort dot nums dot sort, and we'll say left is equal to 0 and right is going to be equal to the length, the last value in the sorted array, right? So length of nums minus 1. So we'll use a while loop to iterate the array. So while, you know what, let me call it this I and j so that it is not confusing. We can use I and j instead. So while I is less than j, right, while I is less than j, then we want to do something. We'll say, let's first of all I'll create a total here. I'll call this a total. This total will be equal to nums at I plus nums at j. Right, now we can say if total, right, if total is less, okay, let's do the superior value self. If total is superior to the target, right, or I did this, or total is equal to the target, right, then we want to move the right pointer. So we'll say right, come on, j plus, no, minus, we reduce it, right, we move it down, minus equal 1, else. So if it's less than the target, right, if total is less than the target, then we do this. We say, we first of all increment, right, we increment the count. So say count is going to be equal to count plus equal j minus I, and then we increment I by 1, so I plus equal 1, and that's all we need to do. So we return the count here. So once we take this, we return the count, and let's test this out to see how it works. So I'll say my solution here, solution is equal to solution class, create an instance of that solution, and then we print the solution dot count pairs. I'll bring these here again. We'll use the same numbers here. You know what, let's just copy this. So let's run this again. Now you can see we have 3. So this solution is faster than the other brute force solution, so we can use this instead. So let me push this to GitHub, and git add git commit slash this is a two pointers question, so I'll say two pointer and this is lead code 2824 lead 2824 like this. Okay, so let's move on to another question. um so here is what other question did I choose today. uh so revision of finding the minimum common value in between two arrays. So minimum common value. Yeah, so this is the question. Now given two integer array nums1 and nums2 sorted in non-decreasing order, return the minimum integer common to both arrays. If there is no common integer amongst nums2 and nums1, return -1. Note that an integer is said to be common to nums1 and nums2 if both arrays have at least one occurrence of that integer. So this is actually a very good question, and we can use different methods to solve this question. So here is what we are given. Here is our inputs. We have nums1, which is equal to 1 to 3, an array with 1 to 3 in it, and then we have nums2, which is 2 and 4. Now we want to find the values that are common to both arrays. Well, there are different methods we can use. There are a couple of methods we can use to solve this question. First of all, we can count the frequency of the numbers, right? And see if at least one of them have, one of them have the same integer. Another way we can do this, we can use a set, right? A set to find the intersection of the set. We can also use a binary search, although I don't believe a binary search will be really fast, but we can use a binary search to find the value. So we can use the binary search. I've solved this before, so you can see there were some questions I was testing out. What did I do here? I probably submitted something that was wrong. Yeah, so okay, so this solution here, I counted and I was returning the count, so it was really slow, right? um let's see another one. This one was fair but not really fast. Let's see, I think this one here was faster but not really oh, okay, this is faster. So here's what I did. Okay, this one is better. So we're using a two pointer method, right? We are setting I and j for both arrays, and the two pointer method is going to work in a way that we move the pointers for each of the arrays. So because the arrays are sorted, right, it means we can start I and j at 0, right, which means index 0. So this will point at the values in each array. So for the nums1 we'll use I, nums2 we'll use j. Now two pointers does not only work for one specific arrays. You can use two pointers for two separate arrays and iterate through. So here's what we do. We take this, right? We take a number at I, which is less than the length of this. So meaning we are going to increment I until one less than the length of this array nums1 here. So we find out if the value at nums1, if the value here is equal to this value, which is at j, the value in the second array. If it is, we return nums1 at I, right, or nums1 at j, whichever one you want to return, because those values will be equal at that point. Otherwise, if it's not, we'll then find out if nums1 at I is less than nums1 at j to increment I, right? If it is, we increment I, otherwise we increment j. Now, why do we increment in this case? Because we know the arrays are sorted, right? From the question, we know for sure that our array are sorted in non-decreasing order. In other words, in increasing order. So meaning we will have larger values towards the end of each array. And if a value in one array is less than a value in the second array, there is a chance that the value that we are looking at in the second array, or we are looking for in the second array, is towards the end of this array here. So we have to increment the count at this point. And the same thing will happen here until one of the arrays, right? One of the arrays reach the end. By end, I mean the last value in the array. Then we terminate the iteration here and return -1, meaning we did not find the value we are looking for. So this is how we solve this question here. And there is a similar question we have to look at too, which is intersection of two arrays. Now this time around, these questions are quite similar, but they are very similar, but the difference here is that we want to return every occurrence, right? At least the minimum occurrence between the two, right? So if they have a value in common, we want to return the minimum value they have in common, the minimum occurrence of that value they have in common. Now when it comes to returning occurrences or returning counts of a particular value in an array, we can use a combination of pointers of counters, right? Let's say counting the values in a dictionary or in a counter class, and then returning the frequency. So if you read this question, given two integer arrays nums1 and nums2, return an array of their intersection, right? Each element in the result must appear as many times as it shows in both arrays. When there's a need for returning the number of times a value appears in an array or in a string or whatever, we need to know that there is a chance that we need to count the values, right? We need to count the values for this. So if you look at my solution, I'll probably use a counter, right, and count the values and return the minimum. So here okay, I'm using a binary search. A binary search will work in this case, that's all right. But let's see here. Now you can see we're using a counter here. We count both values and we find out the minimum frequency between the two counts, right? Between the two counts of that particular value, right? So when we find a value, we have to get the minimum frequency of that value and then return how many times that value appeared in the array. So this is another way to solve that question. Unfortunately, I need to go now, and I will see you guys tomorrow. All right. Thank you for coming to the stream. You can join our Discord channel, our Discord server, to get assistance on programming tasks or anything you are doing programming wise, right? I'll leave a link to the Discord server here. Although I should have done that before, you can get access to our Discord server here. Let me share this invite. So you can get access to our Discord server and join. You'll meet other people there. They are also programmers. You can ask questions. There is a channel for you know assisting you with other programming related tasks. Uh, there are there are a variety of channels that you can ask questions. You can interact with others, and the server is quite small now, but we are growing, right? So it will get to a point where there are a lot of people in the channels and servers, so you can interact with them as well. So I'll post this here. So there's a question for me. Hey bro, where are you learning data structures and algorithm for Python? Um, you can look on Geeks for Geeks, right? Geeks for Geeks has a nice content for learning data structure related topics. You can also check out um, you can also check out the W3 schools. They have also a lot of nice content there. Neatcode.io is really good as well. So check those out. And yeah, so that's it for today. And thank you guys for coming through, for staying through this stream. And I'll see you guys tomorrow. Cheers.